Hi! This week we're going to take a look at the ubiquitous but easily misunderstood type of processing, compression. It's something that's immensely powerful and can make a huge difference to your production, so hopefully this video can help to demystify it a little so you can start to make better use of it yourselves. We'll look at the basic principles of what compression is and how it works, and also look at some applied examples of practical and creative ways to use compression in a production. Let's get stuck in. So, what is compression? Let's start with an example. Have a listen to this drum loop. This loop has moments that are high in level, such as the boom of the kick or the whack of the snare, and it has moments, most of the loop in fact, that are much lower in level, including the strokes played on the hi-hat and the gaps between the drum hits during which we hear the reverberation of the room. The difference between the highest signal level and the lowest signal level in this drum loop is very big, or to put it another way, we could say that it has a high dynamic range. If we were to process this drum loop to make the difference between the loudest parts and the softest parts of the signal smaller, we would be compressing the signal. And this is all compression is. It's a process that takes a signal and turns it down if it reaches a certain level. If the signal goes back below that level again, our compressor turns back up to normal. It's kind of like an automatic volume control, one that can act really quickly or really slowly depending on how we set it. Compression is a type of audio effect that belongs to a category of effects called dynamic processors. A dynamic processor is any kind of effect that changes the level of the signal in some way. If you've ever used a gate to get rid of low-level sounds from a recording, or put a tremolo on a guitar or synthesizer to make the volume wobble up and down, these are both dynamic processors too. How do we actually use a compressor? What does it do, and how do we control what it does? Let's go back to our example loop. Here it is without any processing again. For this demonstration, I'm going to use FabFilter Pro C2 because of its glorious full screen display over here. But all the underlying principles apply to whatever compressor you might be using, including stock plugins. The best way I've heard to explain how a compressor works is to imagine someone sitting at a mixing desk with lots of volume faders in a studio. This is our human compressor, and they're going to move the fader down and reduce the volume whenever it goes past a certain point that we tell them. Let's say it's -6 decibels. This is the first control on our compressor, the threshold. The threshold is the volume level that our human compressor is going to look out for, because whenever the signal goes above that -6 decibel threshold, they're going to bring the volume down a little bit for us. How much they move that volume fader down is decided by the ratio setting. Now the ratio describes the level of the signal coming in compared to the level of the signal going out. So with a ratio of 1 to 1, a signal that comes in at 1 decibel over our threshold also goes out at 1 decibel over our threshold, which basically means there's no compression being applied. At a ratio of 2 to 1, a signal that comes into our compressor 2 decibels over the threshold will come out at only 1 decibel over the threshold. So we'll be reducing the level by 1 decibel. This amount that we're reducing our signal by is what's being represented over here on the gain reduction meter, gain being a word for the level of our signal. This means that at a ratio of 4 to 1, a signal that comes in 4 decibels over the threshold goes out only 1 decibel over, so we have a gain reduction of 3 decibels. In this way, the ratio setting is something like a control over the intensity of our compression, or how much compression is being applied to the signal once it's above the threshold. At around 10 to 1 on the ratio knob, we're getting into the territory of limiting, which is a term that refers to this more aggressive type of compression. If we crank it up to the maximum of infinity to 1, anytime the signal comes in over the threshold, the compressor will completely clamp down and reduce the gain back to the threshold level. This type of extreme limiting is known as brick wall limiting. For this drum loop, we're going to take it back to a medium setting of 4 to 1 and look for a moderate amount of gain reduction, let's say 6 to 9 decibels. Now remember, our compressor who's sitting there at the mixing desk is only human, so there's a bit of a delay between when they see the signal pass over the threshold and when they move the volume fader down. They're not psychic after all. This portion of the process is called the attack time. The attack time is how long it takes our compressor to reduce the level of the signal once the threshold has been exceeded. What happens then, of course, is that the signal goes back below -6 or -12, wherever we've set the threshold, so the person at the mixing desk has to bring the fader back up to its original level, and how long it takes them to do that is the release time. These two timing controls allow us to change the character of our compression to fit the purpose we're using it for. Take this drum loop for instance. If we set the attack time to somewhere around 50 milliseconds, then the compressor is going to let the first portion of each of these drum hits, what's known as the transient, through without much reduction in level. Pairing that with a release time that just about gets our volume control back up to normal in between the beats gives us a very punchy character. The louder parts, the drum transients, the very first part of each of those hits, are exaggerated because the compressor is letting them through, and then we're pushing down the level of the sustain of the drums, so we're actually using the compressor to increase the dynamic range of the sound and getting a very different character as a result. Let's compare that with the dry signal. Now, if we use a very fast attack time, perhaps our human compressor is a little psychic after all, and can react to the signal almost before it actually happens, we're back in the territory of reducing the dynamic range of our drums. Our transients now are actually getting smoothed over and squashed, and suddenly the reverberations of the room are much louder in comparison. The release time is really slow with it set like this. What we end up with is more or less just our compressor keeping the fader down low without much movement. If we speed up the release time, however, the gain reduction moves back up to 0 almost straight away, and our drums take on a much more explosive character. The last thing I always recommend you do when you're setting up a compressor on one of your tracks is to add some makeup gain to match the compressed output with the volume level of the original input. A lot of compressors will have an option to automatically add makeup gain, which is great for comparing different settings, but I'd advise using your ears to manually match the perceived loudness of the processed and unprocessed sounds once you've settled on a setting that you like. The computer can't make a subjective judgment about the way things sound in the way that you can, so let's just do that now. We'll start with the dry. I think that sounds pretty good. Cool. Now, this explosive drum room character sounds great, but we're losing the punch of our drum transients, so let's do something about that. Something we can do with most modern software compressors is to mix some of the original signal back in with our compressed output. Now, on Pro C2, we've got two separate gain controls for the wet and dry versions of the signal, but on other compressors, it might be labeled a mix control or a dry-wet control. Something to watch out for is that in Pro C2 we do actually have a mix control, but this is actually scaling the effect of our compression. It's not actually blending the unprocessed signal in the same way as I'm about to describe, so do be aware of that. Regardless, mixing these two versions of the signal together is what's known as parallel compression, where we compress the signal and we mix it in with the uncompressed signal. We could also use an effects return to do the same thing, but in that instance we would want to keep the mix control at 100% wet and use the level of the effect send to control the balance between the dry and wet versions of the sound. Parallel compression is particularly great for juicing up the sustain of live drums like this while retaining their transient information. So let's have a little go. First of all, I'm going to turn down the wet gain here so that we don't have any of the compressed signal, and I'm going to turn up the dry signal. And then I'm just going to listen by ear to the point where I think it sounds like we've got a good blend going on between the compressed and uncompressed signals. And I think there sounds pretty good. Let's hear it bypassed. our dry drums. Just going to turn the output level down to match the gain level like we did before. There. So we're retaining our transient information, but we're still getting some of that explosive drum room character. Now, the reason why I always say that you should match the perceived loudness of whatever processing you're doing with the original input signal is because the human ear really prefers things that are louder. Like, it just does. We just like things that are loud. So if you are compressing something or processing it in any way, and the result of that is that you get a louder signal, then if you're comparing that louder signal with the original signal, which is much quieter, your ear's always going to prefer, most of the time, is going to prefer that louder version of the signal. Whereas if you match the loudness level by ear of the input and the output, then you can have a much more objective comparison of the two sounds. So you can actually decide whether what you're doing to the signal is improving it or just making it louder, and that's why you prefer it. Anyway, cool. So with just a few tweaks of the attack and release controls here, we could also use parallel compression to exaggerate the transients instead of the room sound. Let's say 10 to 20 milliseconds on the attack, just to let that initial snap of the transient through. And then I'm actually going to slow down the release a little to somewhere where we're actually squeezing the body of the drums like we were before. And I'm going to bring that output level down a little bit again. Let's just hear what our wet version of the signal sounds like on its own. So we're really exaggerating those transients there. And then if we blend in the dry signal again. So in this instance, we're almost doing it the other way around, where the dry signal is a source of kind of our body of the drums, and the wet signal is where all the punch is coming from. So parallel compression is great for enhancing drums without making them sound too compressed and losing the dynamics of the performance of programming. We can emphasize the room sound or the initial transients themselves, and by blending in some of that original signal, we're not losing too much of the kind of natural character of the drums. We can push the compression much further than we would be able to if we were using the compressor 100% wet without introducing too many negative artifacts into the sound. Let's take a look at another example. Here's a recording of someone blowing through a length of hose pipe whilst swinging it around their head, which is a totally normal thing to have. It has a cool sort of trumpety sound, and the movement of the pipe swooshing around gives it some nice kind of timbre change. But the other thing that the movement does is that it makes the level of the signal jump up and down in a way that will make it really difficult to fit in with other sounds in a track. So let's load up a compressor and even out the dynamics here. Now this compressor, we're going to try and catch the loudest peaks of the sample and squash them down. So I'm going to set the ratio to about 8 to 1, which is much higher than we had on our drums. And then I'm going to set the threshold to try and squeeze those loudest peaks of the sound. Might even go a little higher on the ratio there. So for the attack time, we're going to want to keep that fairly fast so that we're not exaggerating the jumps in the signal like we did when we let the drum transients through the compressor when we had the slower attack setting. And then if the release time is really fast, then the compressor is reacting so quickly that it can kind of start to sound a bit odd and distorted. I'm going to exaggerate this effect so that you can hear what I mean. You kind of get this sort of warbly thing going on. When we can hear the compressor acting like this, we might refer to the artifacts that the compressor is adding to the sound. In fact, I think that's a word that I just used earlier. So we don't want the release as fast as possible. I'll stop the sound for now so that we're not going completely mad. We don't want the release time as fast as possible. We want it to smooth things out a little bit more so that it's not eating into our signal and introducing those artifacts. And I'm going to slow this release time down a bit so that we're not warbling around too much. Now, I am just going to match the output level with the input level of the dry signal. We've tamed the louder peaks of the signal, but it's still varying quite a lot in level. We could make the ratio even more extreme, but this starts to sound more and more processed, losing some of that nice kind of naturalistic acoustic character. Likewise with lowering the threshold even more. You heard what that sounded like. So instead, let's drop another compressor on after this first one to even out the dynamics even more. This technique is called serial compression, and it's a really powerful tool on dynamic sources like this, including vocals, guitars, any sorts of acoustic instruments. Where having only one compressor might force us to use really extreme settings and introduce lots of unwanted artifacts, two compressors in series allows us to control the dynamics in subtler stages and produce a more naturalistic sound that still has the dynamic character that we want. On our second compressor, we're going to use a much softer ratio setting, let's say 2:1, with similar attack and release times. And then we're just going to set the threshold to give us a few decibels of gain reduction. Just want to kind of constantly squeeze the signal and average it out a bit. Okay, and then if we match the makeup gain, there we go. So let's just compare the dry signal and our serial compressed signal. So now we have a compressed sample that's not jumping out quite so much between the louder and quieter parts of the sound, and we didn't have to clamp down on it by making one compressor work super hard and introduce lots of noticeable side effects into the signal. This is going to play much nicer with any other elements we want to layer it with now. Let's try processing one more individual sound source. Here's a drum loop. We're going to use the compressor to get some more punch into the transient of this kick drum. The ratio is good at 4:1. I'm going to set the attack time to about 20 milliseconds to let the initial transient and body of the drum through. The release time I'm going to speed up a bit so that the compressor's just about got time to recover in between each beat. And then for the threshold, I'm going to move it until we're getting a good few decibels of gain reduction. We want this effect to be quite noticeable. There, let's just match the makeup gain. Cool. So we've used the compressor to shape the envelope of the sound and give it more punch. If we vary the attack time, this punchiness can turn into a click or squelch on the shorter end. That's quite sort of snappy at around 10 milliseconds. As we speed up even more, get kind of a click sort of character. And then if we slow down the attack, we start to get into more of a kind of thud sort of territory. There's loads of possibilities depending on what you're looking for, And this type of compression on an individual sound source to shape the envelope is something that I do on pretty much every drum track and every mix sound I've ever done. There's so much versatility that you can get out of just varying the timing on these things, so that not only can you emphasize the transients of percussive sounds, but you can also adjust their character, whether you want it more sort of boomy and thumpy or much sort of clickier and snappier. If there are certain characteristics that you're after, you don't just have to rely on EQ to get to them. For one last example, let's try compressing a group of sounds together. We've got our drum loop here, and we're going to stick a compressor across the whole lot to try and glue them together and make them sound more cohesive. This time we'll use a lower ratio of 2:1 with an attack time fairly nippy, about 5-10 milliseconds, and a smooth but quick release at around 50 milliseconds, 100 milliseconds, somewhere around there. And then I'm just going to address the threshold till we get about 2 or 3 decibels of gain reduction. Not loads, we just want to squeeze the dynamics of this drum group and even them out so that each individual sound doesn't poke out on its own quite so much. Match the gain. There. The effect is subtle, but it's these kinds of moves that can help a track really shine when it's finished and gives polish to your mixdown. This subtle compression across a group of sounds is called bus compression, and it can sound great across your whole mix too, as long as you're careful not to over-egg it. It's a great way of making a group of sounds act more cohesively in your mix. So there you have it. We've covered what compression is, how it works, explored the various controls available to us, and applied that knowledge to a variety of sound sources. We've used parallel compression, serial compression, and bus compression to adapt our dynamics for a variety of contexts, and hopefully with everything we've covered, you'll have everything you need to get stuck in with compressors on your own productions. Different compressors will behave differently, especially a lot of more specialised plugins that are modelled after hardware units. I highly recommend getting really used to working with just one compressor to start with, and then get to the more specialised tools when you're confident to do so. Just remember to compare what you're doing with a dry, unprocessed signal, and always remember to trust your ears above all else, and that different sources can shine with different approaches. Go extreme, go subtle, experiment, and have fun with your tracks. Thank you so much for supporting these videos. If you'd like to get your hands on the Ableton session for this video, which includes recreations of all the settings with Ableton's built-in compressor, that's available to patrons at the helping hand level. If you're interested, I'm available for one-on-one tuition and small group courses with priority places for queer, trans, non-binary, black and minority ethnicity folks. You can find out more and get in touch at outsiderspeaks.co.uk for that. Happy compressing, and I will see you next time. Lots of love.